Hey math friends, we're looking at our proportional to linear relations post-test review today. In other words, study guide. So check this out after you try this for yourself too. First one, Random defined two different forms of linear equations. So the first one we looked at was for proportional equations, and then it's simply y equals kx. The next one that we looked at was when we have our slope and our intercept. So this was slope-intercept form. So we have y equals m x plus b. Now, if you missed those at first, they probably sound really familiar now. All right, next one, define all the different types that represent slope. So in proportional relationships, it's always k. In any linear equations, m. It could be y over x. We also think of change in y over change in x. One that we saw briefly, but we didn't practice much for this topic, is y2 minus y1 over x2 minus x1. Now this is exactly change in y over change in x. It's just showing the work for it. We can think of rise over run. And we want to make sure that it's y over x, not x over y, and rise over 1. We can think of another term, I'm going to type it on here, we can say rate of change. When it was proportional, the unit rate was also the slope there. That was the k value. So we have lots of different ways to represent slope. We could have even more. Determine the unit rate for these functions here. So remember, when we do this on a graph, we have to find 2 points that are on this line. So I'm looking for 2 points that are on the line perfectly at the intersection. So like up here, it would be at this point, right? So over here, I'm looking right here. This one is perfect. This one is not. I'm going to delete that. This next one, look really carefully, that's not. But this one right here, that is. Now look at the scaling of our graph. This goes by ones. So this is going to go up 1 over 1, 2, 3. Up 1 over 3. So unit rate would be y over x 1 over 3. And if we divide that, I'm going to get 0.3 repeating. If we think of rounding it, we would probably put 0.33 to help us compare it to other unit rates. All right, next one, it takes Coco 10 hours to walk 6 miles. So think about that in general terms. We want to think about miles per hour, right? So 6 miles divided by 10 hours. And remember, you're going to go ahead on your calculator and divide that. You're going to get 0.6 miles per hour. So not walking too fast, mph, miles per hour. Let's go ahead and circle our final answers here just for consistency too. Number 5 says rank the following representations from least to greatest. So first we have to find the unit rates here. So let's see if they even work. So this is -5 over -1. So I'm going to divide. And if I divide, that's going to be 5. Over here, 10 divided, that's undefined. So this is not proportional. So remember, even if it's not proportional, it still might have a unit rate. So let's look at change in y over change in x. How does y change here? Well, this is -5. Let's see if this is consistent. If it is, then we can use this. -5, -5. All right, now let's look at our change in x. This goes +1, +1, +1. So we do have a consistent rate of change. So this is -5 over 1. And remember, we're going to divide that. So our slope here is -5. All right, next one on this graph, I'm going to find 2 points that are on the graph. So I'm going to mark them in green here. So 1 Remember, look really carefully that it's exactly on there. 2. This one is going to be up 1 over 5. So 1 over 5, and if we do 1 divided by 5, remember y over x. If you do 5 divided by 1, you're getting a very different answer. This is going to be 0.2. Now we really do need to show this work here to be able to do this. Remember right here, this is your slope. There's no negative sign here, so it's 2 over 6. So we need to do 2 divided by 6, and we get 0.3 repeating. Typically we write 0.33 as a decimal approximation. And now we need to write them from least to greatest. So I got a negative number and 2 positives. So, okay, so the negative is the least, right? So the table has the lowest. And then 0.2 and 0.33. Well, the next one would be the graph then. 0.2 or 2/10. And 2/6 or 1/3, which is 0.3 repeating. That would be the equation. So in least to greatest table graph equation here. All right, number 6 is Valerie and Marco's families compare their rates of travel on a trip. Valerie's family traveled at an average rate of 48.75 miles per hour. Marco's family traveled at an average rate of 54.5 miles per hour. Write the slope rate of change as a ratio for each. So Valerie's slope is going to be 48.75 per 1 hour. Marco's similar. His slope is going to be 54.5 miles per 1 hour. All right, so then I need to find out how many miles they travel for each hour. Now we're going to show work here. So in the middle here, and I'm going to go ahead and type this in, this is going to be 48.75 times the distance 0, or times the time 0. So 0. Next one, we're going to show our work, 48.75 times 1, because we have 1 there for time. So it's going to be 48.75 miles. Right? So same thing going through here. So if this was something you were stuck on, please stop, pause the video, and go ahead and try the rest for yourself. Remember, if what you're doing is copying, you're not really helping yourself. So check through with that, look for the patterns, and see that you can do it now. Nope. Let's see, I made a mistake there too, so go back and correct it for yourself. Look at the numbers carefully. It's not 1, 2, 3, 4. All right, and then the same thing for Marcos. So Marcos family, 54.5 times 0. This is showing the work there. So that's part of what we're looking for. And then the rest, we're going to multiply by that input, and so on. And the last one is times 6. $327. All right, so writing an equation here with x represents the time and y represents the distance traveled. So we want mx plus b or kx. So Valerie is 48.75 for her slope. x. And we can write plus 0, or you can leave it like that. Marco, we're going to use his rate, 54.5 x. All right, now we're looking at writing the equations from the graph here. So we want to get slope and y-intercept here. So I'm going to get 2 points that are on this line perfectly. So y-intercept is going to be 0, 0, because it's right at 0 there. And let's find another point that's perfectly on here. This is a little tricky to find here, but you can do it. So I'm finding this one is perfectly on there. Now be careful here. Look, this is 5. These go by 5s. This is 25. So what you're really doing is going up 5 over 25 when you make your slope triangle. And 5 over 25 is going to simplify to 1/5. So my slope here is 1/5. All right, equation, we're going to put y equals 1/5 x plus our intercept plus b is 0. Okay, you could also put that as, you could also write y equals 1/5 x. You don't have to have the plus 0. So I'm going to leave it like that too. And is this proportional or non-proportional? Remember, we can look at the graph or we can look at the equation. I would suggest looking at the graph because this is what you're given. It's linear. It goes through 0, 0. This is proportional. Let's check out this next one. Slope and intercept again. So I'm going to look at, again, right here and find the next point that goes through perfectly right here. And again, this counts by 5s. So this is up 5 over, and look really carefully, 10. 5 over 10 simplifies to 1/2. So we're going to put 1/2 as our slope. And our intercept again is right at 0. So our y-intercept again is 0, 0. So write our equation, y equals mx plus b. We're going to put y equals 1/2 x. Notice that when we write a fraction with x, we put the x next to it. We don't put the x below in the denominator. And we could put plus 0 here. I'm going to simplify that again too. We can write y equals 1/2 x, and we don't need the plus 0 because adding nothing, we'll leave it just like this. I'm going to fix this up. I'm noticing that this doesn't look like a 0 very well there. All right, so then circle one, proportional or not proportional? Well, look at the graph again. It's linear, straight line, goes through 0, 0, so this one is proportional. All right, so look through that again for yourself too as you need to, and we hope that helps you. So study from that and work hard.